In mathematics, two variables are proportional if a change in one is always accompanied by a change in the other, and if the changes are always related by use of a constant multiplier. The constant is called the coefficient of proportionality or proportionality constant. If one variable is always the product of the other and a constant, the two are said to be directly proportional. X and Y are directly proportional if the ratio is constant. If the product of the two variables is always a constant, the two are said to be inversely proportional. X and Y are inversely proportional if the product XY is constant. To express the statement, y is proportional to x, mathematically, we write an equation y equals cx, for some real constant. Symbolically, this is written yx. To express the statement, y is inversely proportional to x, mathematically, we write an equation y equals cx. We can equivalently write, y is proportional to 1x, which y equals cx would represent. If a linear function transforms 0, a and b into 0, c and d, and if the product abcd is not 0, we say a and b are proportional to c and d. An equality of two ratios such as, where no term is 0, is called a proportion. Direct proportionality. Given two variables x and y, y is directly proportional to x if there is a non-zero constant k such that the relation is often denoted using the symbol as, and the constant ratio is called the proportionality constant, constant of variation or constant of proportionality. Examples: if an object travels at a constant speed, then the distance traveled is directly proportional to the time spent traveling, with the speed being the constant of proportionality. The circumference of a circle is directly proportional to its diameter, with the constant of proportionality equal to pi. On a map drawn to scale, the distance between any 2 points on the map is directly proportional to the distance between the two locations that the points represent, with the constant of proportionality being the scale of the map. The force acting on a certain object due to gravity is directly proportional to the object's mass. The constant of proportionality between the mass and the force is known as gravitational acceleration. Properties: since is equivalent to, it follows that if y is directly proportional to x, with proportionality constant k, then x is also directly proportional to y with proportionality constant 1 k. If y is directly proportional to x, then the graph of y as a function of x is a straight line passing through the origin with the slope of the line equal to the constant of proportionality. It corresponds to linear growth. Inverse proportionality. The concept of inverse proportionality can be contrasted against direct proportionality. Consider two variables said to be inversely proportional to each other. If all other variables are held constant, the magnitude or absolute value of one inversely proportional variable decreases if the other variable increases, while their product is always the same. Formally, two variables are inversely proportional if each of the variables is directly proportional to the multiplicative inverse of the other, or equivalently if their product is a constant. It follows that the variable y is inversely proportional to the variable x if there exists a non-zero constant k such that the constant can be found by multiplying the original x variable and the original y variable. As an example, the time taken for a journey is inversely proportional to the speed of travel. The time needed to dig a hole is inversely proportional to the number of people digging. The graph of two variables varying inversely on the Cartesian coordinate plane is a rectangular hyperbola. The product of the x and y values of each point on the curve equals the constant of proportionality. Since neither x nor y can equal 0, the graph never crosses either axis. Hyperbolic coordinates. The concepts of direct and inverse proportion lead to the location of points in the Cartesian plane by hyperbolic coordinates. The two coordinates correspond to the constant of direct proportionality that locates a point on a ray and the constant of inverse proportionality that locates a point on a hyperbola. Exponential and logarithmic proportionality.